Okay, assalamu alaikum everyone. I hope you're all well. Let's begin. This is the paper that we're doing today, March 2026, paper 2, variant 2 for Ad Maths. This is IGCSE O-level Ad Maths. In today's session, we will be completing this full paper, inshallah. It's a free Ad Math past paper session that I'm conducting. If you want to join, you can find the link in the description below, and it will be added to the WhatsApp group where I post when I am about to start a session, when I'm supposed to start a session on a particular day. And I also tell which paper we are conducting on a particular day, so you can attempt that paper beforehand. Chale, let's begin with this March 26 paper 2 variant 2. Walaikum assalam, Azim, and that other cricket guy. Let's begin. Let's start with this. We're doing this complete paper, okay? First question. Can somebody please confirm, by the way, if you can hear me clearly today, because we had to stop the previous stream in the middle because my voice was distorted. Do let me know if it is okay today because I am using a workaround today. Hopefully it works fine. Yes, okay. Thank you. Chale, let's start with this first question. So they're saying the function f is defined by this for all real values of x. Write f of x in this form. So we have to write it in completed square form. We have to write it in completed square form. How can we do that? Remember, the standard completed square form is this: a into x minus h whole square plus k. A is the same number as the coefficient of x squared here. H and k are the coordinates of the turning point. It's a quadratic function, right? H and K are the coordinates of the turning point. You can find those coordinates directly from your calculator. It's a calculator paper. You're allowed to use a calculator. You can just input that function in your calculator to get the turning point. All you have to do is on this version, class Viz, go to menu, and then this equation solving function, polynomial, degree 2, input the coefficients. 2, -6, and 4. You'll get the x-intercepts first, 2 and 1, and then you get the x-coordinate of the turning point, which is 3 over 2, and the y-coordinate of the turning point, which is -1 over 2. The value for h is 3 over 2. The value for k is -1 over 2. All you have to do is input those values in this function and you'll get the completed square form. There is no working required in completing square questions. The 3 marks that you have here, they're only for the final answer. So when you write it like this, the value for a is 2, the value for h is 3 over 2. So that will be x minus 3 over 2 whole squared plus k, the value of k is -1 over 2. That's your final answer. 1 mark in this case is going to be for this number 2 outside, 1 for this number -3 over 2, and 1 for this number -1 over 2, and that gets you full marks. ठीक है? I would recommend that you get this calculator. This is ClassWiz, the white version, the white model that many of you would have seen. Let me see if I can show that to you here as well. ClassWiz 991EX. This is FX991EX. It's this model that you must have seen many people have, this white model. I recommend all my students this model because it helps in a lot of calculations. It will help you a lot in A levels as well later on. Can you do that in a Casio 570 ES? I'm not sure. Many other calculator models, they don't have the turning point thing in them. So I'm not sure if we can do that in that other calculator. What about P1 live streams? We will have them, you mean A-level maths paper 1, we'll have them closer to the exam inshallah in June. These ad math streams, by the way, are going to be helpful for A-level math P1 paper as well because there's a lot of overlap between A-level math P1 syllabus and ad math syllabus. So you might find many of these questions helpful for your P1 preparation as well. Chalo, let's have a look at the second part now. It says, hence find the range of f. It's a quadratic function. How do you find range of quadratic functions? You think of the graph of the function. What kind of graph is this going to be? It's a U-shaped curve, right? It's a U-shaped curve. It'll look like this. Now, all you have to do is think about what's the lowest point of this graph and what's the highest point of this graph. What's the turning point? We found the turning point in the previous part. That was 3 over 2 and negative 1 over 2. That's the turning point. The turning point is 3 over 2 and negative 1 over 2. Now, on the y-axis, you could say the lowest value, the least value is negative 1 over 2. So you can be anywhere greater than or equal to negative 1 over 2. Okay? Anywhere greater than or equal to negative 1 over 2. So that will be your range. The range of the function represents the y values of the function. The y value has to be greater than or equal to negative 1 over 2. That's what you write down as the final answer. Okay, let's move on. Now they're saying the function g is defined by 2x squared minus 6x plus 4. Now this expression looks familiar because we have seen that here as well. F of x had the same expression. The only difference was f of x was defined for all real values of x. G of x, on the other hand, has a restricted domain x less than or equal to k. Now, given this domain, what's the largest possible value of k such that g has an inverse? Acha, if g has an inverse, what does that mean? If it has an inverse, it's a one-to-one function, right? It's a one-to-one function. Now, a quadratic function originally is not one-to-one because this, if you think about this whole curve, it fails the horizontal line test. We can draw this horizontal line, it cuts the graph at 2 points, so it's not one-to-one. However, if we only consider the right side of this part, or only consider the left side of this part, those two parts individually, they would be one-to-one. Now, they are saying x is less than or equal to k. So on the x-axis, we've got some value that is k. Now, x-axis may be somewhere around here. Now, there's some value k such that to the left of that, the function is one-to-one. So for example, k might be here, let's say. To the left of this, it's a one-to-one function. But is this the largest possible value of k? No, you can still keep going on to the right side. It will still be one-to-one. You can keep going on until you reach the turning point of the function. If you go any further than the turning point, then it will no longer be one-to-one because then you can draw this horizontal line that cuts the graph at more than 1 point. It will not be one-to-one. You can only go up to the turning point. So what's the value of k here? At the turning point, what's the x coordinate of the turning point? It's 3 over 2. That will be the largest possible value of k. You would say the largest possible value of k is 3 over 2. That's a standard thing. That's a standard thing that we do in all such problems. In problems like this, when you have a quadratic function involved, sometimes they ask you for the greatest value of a constant such that the function is one-to-one, or the least value of a constant such that the function is one-to-one. In all such cases, it will be the x coordinate of the turning point because of the reason that we just discussed. ठीक है. So the largest k in this case is 3 over 2. And that's our final answer. Okay, let's move on. Part D now. Part D. Now we have another function h of x that is defined like this for x less than or equal to 0. Given that gh of x exists, find gh of x simplifying our answer. All right, let's find gh of x. Gh of x. What that means is inside the function g, we have to input h. Now, what's the function h? H is e raised to the power 3x minus 1. So inside the function g, input this. Now, what was function g? Let me write that down here as well. The function g of x that we had, that was 2x squared minus 6x plus 4. And the domain of that function g that was less than or equal to k. So inside g now, we need to input h. So in place of x, in that function, we input this thing. And that gives us 2 into e raised to power 3x minus 1 whole squared minus 6 into e raised to power 3x minus 1 plus 4. Now that's the gh of x function, but they also want us to simplify this. So you have to expand this as well now. This is a square. A minus b whole squared is a squared minus 2ab plus b squared. That is what you would do to expand it. E power 3x whole squared. What will that be? E raised to power 6x. The powers get multiplied. 3x into 2 minus 2 into e raised to power 3x into 1. That will be 2 e raised to power 3x plus 1 squared is just 1. Simplify the rest of it as well. E power 3x into 6 minus 6 into minus 1, which is plus 6 plus 4. Simplify this further and you get 2 e raised to power 6x minus 4 e raised to power 3x plus 2 minus 6 e power 3x plus 6 plus 4. And that gives us 2 e raised to power 6x minus 4 minus 6. That will be minus 10 e raised to power 3x plus 12. That is the function gh of x that we were looking for. ठीक है. Any problems with this? Make sense? This is simplified form. If you write it in brackets, that will be factorized form. So you'll just leave it as it is. This is the final answer. Okay, chale. Let's move on to the next one now. This was part D. Question number 2. Let's do this now. Now they're saying points A and B have these coordinates. The point P with these coordinates lies on the perpendicular bisector of AB. Find the value of A. Okay, so this point, 2 and A, it lies on the perpendicular bisector. If it lies on the perpendicular bisector, what that means is it should satisfy the equation of the perpendicular bisector. So what we can do is we can find the equation of the perpendicular bisector and input this point in that. Let's do that. How do you find equation of perpendicular bisector? We can find the gradient of AB first of all. What is that? y2 minus y1 over x2 minus x1, 1 minus 3 divided by minus 7 minus 1, which is minus 2 divided by minus 8. That simplifies to 1 over 4. That's the gradient of AB. What about the gradient of the perpendicular of AB? Negative reciprocal of this, which is negative 4. So we have the gradient of the perpendicular bisector. We also need a point that lies on the perpendicular bisector. Do we have a point? It's a very common error that students end up using one of these 2 points. Perpendicular bisector is not going to pass through A or B. It is going to pass through the midpoint of A and B. What's the midpoint? Let's input values in the midpoint formula. 1 minus 7 over 2 and 3 plus 1 over 2. What does that give us? The coordinates of M, they turn out to be negative 3 and 2. This is the point M that we've got. Okay, so we've got the point and we have the gradient. Let's write down the equation of the perpendicular bisector. Y minus 2, that equals M, which is minus 4 into x minus minus 3, which is x plus 3. That's the equation of the perpendicular bisector. Now, they told us this point P lies on this point P lies on the perpendicular bisector. So all we have to do now is input that point in this, put 2 and A. 2 is the x value, A is the y value. So that will give you A minus 2 equal to minus 4 into 2 plus 3. That simplifies to A minus 2 equal to minus 4 times 5, which is minus 20. A equals minus 18. And that is what we were looking for. That's our final answer. A is equal to negative 18. Any issues with this? Makes sense, right? Okay, that was part A, fairly straightforward. Let's look at the next part now. Now they're saying the point Q is the reflection of P in the line AB. Find the coordinates of Q. Okay, Q is the reflection of P in the line AB. How do we find the coordinates of the point Q from this? Let's try to visualize. Let's try to visualize and see how this would look like. So we have this point A, we have this point B. We already have the perpendicular bisector of AB as well. This is what it might look like. We know the midpoint's coordinates. Midpoint is -3 and 2. Point A has coordinates 1 and 3. B has coordinates, although they don't matter. Let's just not write them. We have the midpoint, that is -3, 2. That is important. They're saying Q is the reflection of P. P has coordinates 2 and A, which means 2 and -18. So it might be on this side somewhere. P is 2 and -18. That's the point P. Okay. Now, Q is a reflection of this in the line AB. Where will point Q be? On the other side of AB, such that its distance from the line AB, perpendicular distance from the line AB, is the same as that of P on the other side. So this point -3, 2, this is also going to be the midpoint of PQ. So you can either use the midpoint formula to find the value of Q. That is one possibility. You'll get that. Another quicker way of doing this is the vector method. You write it like this. You say, whatever is the number of units that you need to go towards the left side to go from 2 to -3, that's 5 units, right? That's the same number that you would go further to reach the point Q. So you go further -5, so -3 -5, that will give you the x coordinate of Q, which is -8. Similarly for the y coordinate as well. I like to write it like this. Write P. P is 2 and -18. Then write Q. Write midpoint first, which is -3 and 2. And then write Q. And think of it like this. How many units do you have to go in order to reach -3 from 2? You have to go -5 units. Since M is the midpoint, you go -5 units more in the x direction, and that will give you -8. Similarly, how many units do you need to go in the y direction to go from -18 to 2? You need to go 20 units plus 20 units. So you go plus 20 units more, and that will give you the corresponding y coordinate for Q. And that's your final answer. The coordinates of Q, therefore, are -8 and 20. That's what we were looking for. Okay. Is that all right? 22, sorry. Yeah, 2 plus 20, that's 22. -8 and 22, that's your final answer. ठीक है. All right, that was part B of this. Let's move on to the next one now. Okay, so now we've got this graph. The diagram shows the graph of y equals x plus 1 into x minus 1 into x minus 3. It's a cubic function. It's a cubic function. By drawing a suitable line on the diagram, solve this inequality. Okay, now how do we think about this? Look at the inequality. On one side of the inequality, you have this function y equals x plus 2 into x minus 1 into x minus 3. That's one function that you've got. On the other side of the inequality, you have 7. Now the graph that you have drawn there, that is of this function, the cubic function. You can say that is y. So what you're looking for is y greater than 7. When is y greater than 7? That is one way to think about this. Another way to think about this could be, you could say you have one function on the left side, that's y equals x plus 2 into x minus 1 into x minus 3. And you have another function on the right side, you could say that's y equal to 7. You are looking for the values of x where this cubic function is above this straight line. That will be the solution of this inequality. So what you can do for that is, you can make this line on the diagram y equals 7. They have mentioned that you have to draw that line, so you will not get full marks unless you draw that line. So you should do that. Y equals 7 line, that's going to be a horizontal line. At y equal to 7, it will look like this. So you draw this line. Now see where exactly this line is intersecting the curve. It's intersecting the curve at at 3 points. This is one point that I can see here. It's almost on that line, so we can run it off that line. This is okay. This is -2. This is -1. So that point is -1.3. Okay. Just mark those points for now. We will see what to do after that. Mark the points of intersection. These will be the solutions of the equation. If this was equal to 7, we would have these solutions. Let's mark them, and then we will think about the inequality after that. Another point of intersection that we're getting here is -0.2. This is another point of intersection. And another point of intersection is here, which is almost at this line. This is 3, so this point is going to be 3.5. Okay, so we've got the points of intersection, x equals -1.3, -0.2, and 3.5. Now the inequality that we are solving is, where is the cubic function above that straight line? Where is the cubic function above the straight line? Because there's a greater than sign. So let's see which regions are they. This is one region where the curve is above the line, and this is another region. So on the x-axis, we could say between -1.3 and -0.2, or to the right of 3.5. So the final answer that you would write based on that would be -1.3 is less than x, which is less than -0.2. So x is between -1.3 and -0.2, or you write a separate inequality, or x is greater than 3.5. And that will be your final answer. You cannot write this inequality in two parts. It has to be in one single part like this. And then the other inequality you can write separately. And that will be your final answer. Any questions on this? Any problems, anyone? No problems? ठीक है, चलें, let's move on to the next one now. Now they're saying a 6-digit number is to be formed from the digits 1, 2, 3, 4, 5, 6, 7, 8, 9. No digit may be used more than once in any 6-digit number. So a 6-digit number is supposed to be formed. Numbers cannot be repeated. Find how many 6-digit numbers can be formed in the following cases. There are no further restrictions. So the only restriction is that no digit can be used more than once. Okay, that's the only condition that we've got. Now there are 9 digits. You want to make a 6-digit number. You can think of it like this. You've got 9 objects. You want to arrange them in 6 places. How can you do that? 9p6. And that should give you the result. Just put this on a calculator. Alternatively, you could say for the first place, you have 9 options. For the second, you've got 8 options, then 7, 6, 5, and 4. So 9 into 8 into 7 into 6 into 5 into 4. And that will give you the same result as well. That will be an alternative to this. Okay, put this on a calculator. You can't leave it like this. You have to simplify this. Let's see what we get from that. 9p6, and that gives me 60,480, and that's your final answer for the first part. That was fairly straightforward, easy 1 mark. Now they're saying the 6-digit number includes the digit 4. Okay, how do we think about this now? The 6-digit number, it has to include the digit 4. 4 has to be there. Now, let's think about it. We could say it's a 6-digit number, so we have 6 places for the 6 digits. We have 6 places for the 6 digits. Now, out of those 9 digits, 4 has to be selected. 4 has to be in this 6-digit number. Okay. So what we can do is we can break it into 2 parts. We could say 4 definitely has to be one of those digits. Okay. Now, if 4 is already there, how many digits are we left with? 3 and 5, that's 8 digits in total. How many more digits do we want apart from 4? We want 5 more digits to make it a 6-digit number. So what you can do first is you can select which 5 digits are going to be there. How do we select? 5 digits out of 8 digits, not 9, sorry. 8C5. 8P5 is not going to work. I'll tell you why. It will be 8C5 first of all. What you're doing here is you are selecting 5 digits that you are going to put in these boxes. Okay. Once you have selected those 5 digits, remember arrangement also has to include this digit 4. If you do 8P5, you would just be arranging those 5 digits. You also want to arrange this digit 4. So one way to do this could be, you could say, do 8C5, do 8C5, and then once you have the 5 digits selected in addition to 4, you arrange those 6 digits now. In how many ways can you do that? 6 factorial or 6p6. You have 6 places, 6 objects, arrange them. They can be arranged in 6 factorial ways. Multiply these two numbers, and that will give you the result. Let's see what we get from this. 8c5 into 6 factorial. 8c5, that is 56 into 6 factorial. And that gives us 40,320. And that's our final answer. Does that make sense? Any issues with this? If you do 8p5, you'll have to arrange 4 separately then. So you could say 8p5 for those 5 digits apart from 4. You could do that. But then remember, you are not arranging this 4. So you have to arrange 4 separately in that case. How many places do you have for 4 in that case then? It could come in this current position, or it could come here, 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 or here. That's 6 places in total for one digit 4. So you would multiply it by 6 for that reason, or you could say 6p1. And that should give you the same result as well. But keep in mind, 8p5 is not going to arrange 4 alongside. So you'll have to do that arrangement separately in that case if you do decide to do it this way. That's an alternative way of doing this as well. Okay, चलें, let's move on. Let's move on to the next one. Now they're saying a class consists of 10 girls and 12 boys. A group of 6 students is to be selected from the class. There must be at least 2 girls and at least 2 boys in the group. Find the number of different selections that can be made. Now that's a standard question. at least two girls and at least two boys, when they have a statement like this, at least a certain number, that means you have to make cases, right? Because at least two means it could be two, it could be three, four, and so on. So you have to consider all the possible cases that would satisfy the given condition. Now, what are the possible cases? Let's list them down. The number of girls that we've got is 10. The number of boys that we have is 12. How many boys and girls need to be selected? At least two girls and at least two boys. Let's make the cases. Now, do it in a structured way so you don't miss out on any important case, any relevant case. Do not miss out on anyone. So do it in a proper order. So you do it like this. You say, okay, it says at least two girls. So start with two girls and see how many boys are possible with two girls. With two girls, you can have four boys. That makes the total number six. Then the next number of girls could be three. With three girls, how many boys can you have? Three. Then with four girls, you can have two boys. Can we have five girls? No, because if we have five girls, then we need one boy. It doesn't satisfy the other condition. So the only three possible cases that we end up getting are these. So now you say, in the first case, out of 10 girls, you want to select 2, so that's 10C2. And out of 12 boys, you want to select 4, so 10C2 into 12C4, that will give you something. In the second case, 10C3 into 12C3. In the last case, 10C4 into 12C2. And that will give you the result. You can see what this turns out to be. So it's either the first case or the second case or the third case. You add up all the cases at the end, and that will be the final answer. Let's see what we get from this. 10C2 multiplied by 12C4. That's 22275. Then the second case, that's 10C3 into 12C3. Let's see what we get from this. That's 26400. And then finally 10C4 into 12C2. And that is 13,860. Add up all of these numbers, see what that gives you. This plus 26,400 plus 22275, and that's giving me 62,535, and that should be your final answer. Okay. Not that difficult, right? That was pretty straightforward as well. Let's move on to the next one. Question number 5. Now they're saying the diagram shows. So what keyword in the question shows combination or permutation will be used? I would recommend that you try to understand the question, the context of the question. Generally, mostly for permutation, you will see arrangement. You'll see the word arrangement, arrange or arrangement. Okay, that's what you will see for permutations generally. For combinations, in general, you will see the keywords like selection, select some objects, choose some objects, make a group of people, make a team of people. So one of these different keywords. But remember the general rule. When the order of objects that matters, in that case, it's permutation. When the order is not relevant, in that case, it's combinations. Because in this example, you see, they wanted us to make a 6-digit number, and they have not used the keyword here. They have not used the keyword arrange. That's the keyword for permutation, right? They've not used that keyword. But the context tells you when you're making numbers like this, then the order is important because 1, 2 is different from 2, 1. One is 12 and another is 21. The context of the question tells you that order is important. Generally, for numbers, order is going to be important. So you use permutation there. So in the first two parts, that's why we used permutation. And the second part, just they're talking about selections. Selection means we only care about the group of people that we've got. We don't care the order in which they were selected. Okay, so select is a keyword for combination. So that tells you have to use combination. Okay, so for permutation, arrange is the keyword. For combination, select, choose, group, team. These are some of the keywords that you see, but it's more important to remember the logic behind them. Okay. When order matters, it's permutation. When order does not matter, it is combination. Okay. The diagram shows a design for a badge. ABC is an equilateral triangle with side x centimeters. Okay, this is x, this is x, this is x. These arcs are part of a circle with center A. Okay, so these are parts of three circles. One with center B, you'll have this arc. With center A, you would have this arc. And with center C, you would have this arc. Okay. Okay, now they're saying ABC is an equilateral triangle. Okay, we've read that already. Write down the size of the angle ABC in radians. It's an equilateral triangle. Each side is 60 degrees in radians. That is pi over 3. So you just write that. That's just one mark. Just write that number. Take it. Pi radian is 180 degrees. Divide that by 3. That's pi over 3. Now they're saying the area of this badge is this. Find the value of x given that. Okay, so to find the area of the badge or to find the value of x, what we can do is we can find the area and equate it to this, and that should give us the value for x. Now we have to plan how to find this area. Which areas do we need to calculate and add up together to get the total area of this badge? One is a triangle in the middle. So we have to find the area of this triangle. That's one thing that we need to do. Then we need to find the areas of these segments. These are segments, right? We need to find the areas of these segments. These are all equivalent to each other. These are all equal segments. So what we can do is we can find the area of one of these segments and multiply that by 3. Okay, so it's triangle plus those 3 segments. What I'll do is I'll first find the area of one of those segments. Or let's find the area of the triangle first. Area of triangle ABC, because we need to use this for area of segment as well then. Area of the triangle, how do we calculate that? Angle in the middle is pi over 3. We can use half AB sine C. So half into x into sine of the angle between them, which is pi over 3. Okay. Now let's simplify this. Half x squared into sine pi over 3. Sine pi over 3, put this on your calculator. Its value is under root 3 over 2. Make sure your calculator is in radian mode for this. You can just put this on a calculator, although you should remember these values as well because they are important for paper 1. Okay, we get under root 3 over 2. Okay, this is the area of the triangle ABC. Under root 3 over 4 x squared. Achha. What about those segments now? Let's find the area of this segment, for example. Let's find the area of this yellow segment. How can we do that? We can say it will be area of this sector minus the area of the triangle. So area of one segment, let's find that. Area of one segment. Let's see what this turns out to be. Area of sector, which is half r squared theta, right? What's the radius of this sector? It will be x, right? X is the radius of that sector. So you can say half x squared into the angle, which is pi over 3, minus area of the triangle. What's the area of the triangle? We found that earlier. That's under root 3 over 4 times x squared. Simplify this. This gives you 1 over 6 pi x squared minus under root 3 over 4 times x squared. That's area of one segment. The total area of the badge is given. So now what we can do is we can say the total area, what does that turn out to be? That's under root 3 over 4x squared. That's the area of the triangle plus 3 segments. So 3 into 1 over 6 pi x squared minus under root 3 over 4x squared. This should equal that value that they gave, 2 pi minus 2 under root 3. Okay, so equate it to that and solve for x now. Let's see what we get from this. I'll simplify this first. Under root 3 over 4 x squared. Now remember, we can't use decimals because the area is given in exact form. So you have to convert it to exact form. Under root 3 over 4x squared plus 3 over 6, that will be 1 over 2 pi x squared minus 3 under root 3 over 4 x squared. This is what we end up getting. What you can do now is you can actually subtract these two terms. This term, where did that go? Sorry. These two are like terms, right? This term only has x squared in it. This term also has only x squared in it. We can subtract them. They have the same denominator as well. If we subtract the numerators, under root 3 minus 3 under root 3, what will that become? Minus 2 under root 3 divided by 4 x squared plus 1 over 2 pi x squared. Okay. Now we can simplify this a bit further. This is cancelled and this gives us 1 over 2. We can take x square common from this. Take x square common and see what that leaves us with. Or in fact, just keep it as it is. Just keep it as it is. Just simplify. I'm going to rearrange this. I'm going to rearrange this, write this term first and this term second, because the area that they gave us, that is in this form, right? So pi term first and then the under root 3 term second. So I'll write it rearranged like this, 1 over 2 pi x squared minus 1 over 2 under root 3 x squared. Okay. Now what we can do is we can compare both of them. We can compare them. We can say this is the area that we are getting. The area that they gave us, that was 2 pi minus 2 under root 3. This was the area that they gave us. You can compare them. This must equal 2 pi. And this must equal 2 under root 3. Equate any of them, you'll get the value of x. If I equate the yellow ones, that gives me 1 over 2 pi x squared equal to 2 pi. Pi and pi get cancelled and we get x squared equal to 4. And that gives us two possible values of x, plus minus 2. However, x represented the length of a side, so it cannot be negative. The only possible value of x that we get from this is 2, and that's our final answer. Okay. So they gave us the area of the badge themselves. What we did was we found the area ourselves in terms of x, and then we compared that area with what they gave us there, and that gave us the value for x. This is one way of doing this. You could also just solve this equation, take x square common. That could be an alternative. You could take x square common here. Whatever is inside the brackets, you could divide that on the other side. And that would also give you x squared equal to 4 and hence x equal to 2. That could be another way of doing this as well. And that will also work. Okay. Any problems with this? Make sense? Sure, let's move on. Now they're saying in this question number 6, the diagram shows part of this graph y equals 1 plus tan half x, where x is measured in degrees. Write down the period of 1 plus tan half x. Okay. What's the period of tan graph? What's the period of tan x? What's the period of tan x? It's in degrees. Okay, so that's 180 degrees. When they do 1 plus something, that is just going to do vertical translation, right? The graph is going to move 1 unit in the upwards direction. Period is going to change because of this half x. So x is divided by 2. What does that tell you about the period of this graph? When you divide x by 2, what happens to the period? Period gets multiplied by 2. So its period is going to be 180 multiplied by 2, which is 360. Okay, there's no working required for this. You just have to write down the final answer. You can do it in your head as well and write down the answer, and that's okay. But the reason why it is 360 is the original graph has a period of 180. This graph, it has x over 2 in it. So it's going to get multiplied by 2, the period. Okay. Achha, now they're saying write down the equation of the asymptote A. What's the equation of this asymptote? Let's think about this now. Remember, in the original graph, the tan graph, the first asymptote is at 90. Right? When you draw that graph, it starts from 0. It becomes an asymptote like this at 90. The second asymptote is at 270. This is half x. There's a stretch, there's a horizontal stretch by a factor of 2. Period is getting multiplied by 2. So this 90 would have become 180 in this. That this also gets multiplied. The asymptote in the original graph was at 90. Now it becomes 180. And this other asymptote, this also gets multiplied by 2. And this is now going to be at 540. Okay, because the period is getting multiplied by 2. So all the x values, they get multiplied by 2. The asymptote that was at 270 earlier, now that is going to be at 540. That's what you write down there. What's the equation of that asymptote? It's a vertical line. X equals 540. That's the equation of that asymptote. Okay. So this would be 180 and this would be 540. Why are we getting 540 here? We are doing 270 multiplied by 2, and that's 540. All right, now they're saying, on the axis below, sketch the graph of y equals 3 cos 2x plus 1 for x between negative 180 and plus 180. Now, if it was a non-calculator paper, we would think of the cos x graph. We would think of the cos x graph. This is what it looks like. Then we would think of transformations that, okay, the graph moves 1 unit up, its amplitude is 3, its period gets divided by 2. So it gets compressed by a factor of 2, right? Or stretched by a factor of 1 over 2 horizontally. But this is a calculator paper. We don't have to think about all of that in this case. Just remember the shape of the cos graph and make a table on your calculator. Menu, table function. What's the function here? In radians? No, sorry, it has to be degrees. So make sure that you're using the correct mode on your calculator. Whenever you're about to do something that involves a trigonometric function, sine, cos, or tan, always look at the top of your calculator. It should show D there, uh, in case you're using degrees, and R there in case you're using radians. ठीक है? अच्छा. Let's input that. 3 cos of 2x plus 1. That's the function. Skip the other one. There's only one function that we need to draw here. Start. Where do we start? The first value, negative 180. Where do we end? Final value, 180. What's the step going to be? Generally, I recommend whatever is the gap between the smallest and the largest value, that's 360, divide that by 8. And you'll have a sufficient number of values. 360 over 8, that's 45. Take a step of 45. Although 90 would also be sufficient as long as you remember the shape of the graph, that will also work. I'm doing this, I'm using 45 as the step. If I use 45 as the step, I have these values. At minus 180, there is 4. So this will be 4 here. This is 1 point that I've got. At minus 90, let's actually plot all of them. At minus 135, I've got 1. So it will be here. Then the next value is negative 2. This is negative 2. At negative 45, it is 1 again. And then it becomes 4 again. And then it will be 1 again. And then negative 2. And then 1 again. And then 4 again. Okay. So you plot all of those values. Now, what shape do you draw through those points? The standard cos shape, or sometimes a reflection in x-axis. Sometimes you can get this shape as well if there was a minus multiplying outside. Just draw that shape now. So graph is going to look like this. It will be in this direction first. Then it will change direction here, go in the other direction like this. Have a turning point at the bottom. Then it will go up. Change direction at this point. Have a turning point here. Always do it with a pencil so that you can smooth it out if you are not able to draw it in one go. I generally need to do that a lot. Never do it with a pen. This is what the graph is going to look like. And that's your final answer. The last part as well. Missed that. Okay, that's your final answer. This is what we were looking for. Not too complicated, right? Let's look at the next one now. Question number 7. Now they're saying a ship is sailing with speed v kilometers per hour. The sailing cost per hour is given by this. Find the speed that makes C a minimum. Justify that this value of C is a minimum. Okay, so we have this function. For C represents the sailing cost. We have to find the minimum value of that cost. To find the minimum value or the maximum value of any function, what do? We find the derivative, put that equal to 0. That's exactly what we would do here as well. Find the derivative of this function, put that equal to 0. Let's do that. First of all, what I'll do is I'll write it in the power form, bring that v from the denominator to the numerator, so it becomes v squared plus 3000 v power negative 1 plus 100. Find the derivative of this. Derivative of v squared is 2v plus derivative of this thing, that is going to be minus 3000. When power gets multiplied, then you subtract 1 from the power, it becomes minus 2. Derivative of 100 is just 0. Now you put this equal to 0 because you're looking for the minimum point. The derivative has to be 0 at that point, right? So put this equal to 0. That gives you 2v minus 3000 over v squared equal to 0. Multiply the whole equation by v squared so that the denominator gets eliminated, and we're left with 2v cube minus 3000. That gives us v cube equal to 3000 divided by 2, which is 1500. And the value for v that we get, that is cube root of 1500. That's your exact value. You can leave it like this if you want. That's okay. Since they have not specified that you want an exact value, you can also write decimals. That will also be fine. Now you have to justify that it's a minimum value. How do we justify that? Find the second derivative. If the second derivative turns out to be positive, it's a minimum value. So now you have to find the second derivative as well. Let's do that. This was the first derivative. Let's find the second derivative. That is going to be 2 minus minus 2, which becomes plus 2 into 3000 into v raised to power negative 3. Simplify this to get 2 plus 6000 divided by v cube. That's your second derivative. Input that value for v in this. What do we get? 2 plus 6000 divided by cube root of 1500 whole cube. So you just have 6000 over 1500. which is 4. 2 plus 4, that is 6. That's a positive number. Since the second derivative is positive, you say that is going to be a minimum point. This is a minimum point. Okay, because the second derivative is positive, it's supposed to be a minimum point. All right. That was 5 marks, easy 5 marks. This is all that we had to do in this. Acha. Now they're saying, hence find the minimum sailing cost for a journey of 150 kilometers. Okay, so what we know is the cost is going to be minimum when speed is this. Now, if they travel a distance of 150 kilometers, we have to find the total minimum sailing cost. Okay, so the distance is 150 kilometers, and the cost is going to be minimum at this. Okay, that's why sailing cost per hour. Okay, all right. So the sailing cost is actually given per hour. This is per hour sailing cost. Okay, all right. So what we can do is we can find the time taken for this journey, right? Because the cost is going to be minimum at this particular speed. How much time does this journey take? Let's figure that out. Distance is 150 kilometers. Speed is given in kilometers per hour, so there's no problem with units. 150 divided by cube root of 1500. See what we get from this. What's the time taken that we get? Let's figure this out. 150 divided by cube root of 1500, and that is giving me 13.1037. Okay. Now this is the number of hours. This is the number of hours that this particular journey is going to take if it is traveling at this speed when the sailing cost is going to be minimum. Now, once we've got the time taken, what we can do is we can find the value of the sailing cost per hour. So find the value of sailing cost, put the number in this, the speed number in this. That will give you a value for C. They did not ask for that in the first part. That's what I was checking earlier. They just asked for speed in the first part. We found that. Now, what is that minimum C value? Let's figure that out. What we can do for that is we do it on the side here. The sailing cost per hour function is V squared. That means 1500 cube root of this. And then whole squared, that will be power 2 over 3 plus 3000 over V, which is cube root of 1500 plus 100. This will give us the sailing cost per hour. Okay? Let's see what this turns out to be. Put this on your calculator, the whole thing. 1500 raised to power 2 over 3 plus 3000 divided by cube root of 1500 plus 100. And that is giving me 493.1112. This is the sailing cost per hour. The unit is in dollars. This is this many dollars per hour. What's the total cost going to be if this is the number of hours? Let's just multiply those two numbers. That's 493.1112. That's for 1 hour. Multiply this by 13.1037. And that will give you the total sailing cost for the journey. What do we get for that? This multiplied by 13.1037, and that's giving me 6,461.581. This is not an exact number. You can round it off to three significant figures, and that will give you 6460. That's the cost of sailing that we have in this case, the minimum sailing cost. Makes sense, right? Any issue with this? So this was important to note here. The sailing cost given was per hour. So we found the time taken, just multiplied that by the number of hours that we had. ठीक है? Okay, let's move on. Now we've got the circle. A circle has this center at -2, 0 and radius 5. Okay, I'll just do this question and then I'll have a short break of 30 seconds. I need to bring some water. Then we'll see. Okay, a circle has this center and radius 5. A line has this equation. The line does not meet the circle. Does that remind you of something? Line does not meet a function that has some quadratic terms in it. Circle has quadratic terms, right? X squared, y squared. Line does not meet the circle. We could say b squared minus 4ac, that is supposed to be less than 0. What we want to find is the set of possible values of k. What we do for this now is we can write down the equation of the circle first of all. What's the equation of circle given by? It's x minus a whole squared. It's also given in the formula sheet for you. Plus y minus b whole squared equals r squared, right? That's the equation of circle. X minus minus 2, that becomes x plus 2 whole squared, plus y minus 0, that's just y squared, equals 5 squared, which is 25. That's the equation of the circle. Equation of the line that we have got is y equals 2x plus k. Now, since the line and the circle, they do not meet each other, if we try and find the point of intersection by equating them or by using substitution, we can't equate, but we can use substitution here, we should get no solutions for that. So what we can do is we can say, let's input y equal to 2x plus k in this equation and the circle equation. What does that give us? X plus 2 whole squared. I'll simplify that. So it gives me x squared plus 4x plus 4 plus y squared. That means 2x plus k whole squared equals 25. Simplify everything and that will give us x squared plus 4x plus 4 plus 4x squared plus 2 into 2x into k. That's 4kx plus k squared minus 25 from the other side. This is what we get. Now x squared plus 4x squared, that is 5x squared. 4x and 4kx, you take x common, and that leaves you with 4 plus 4k times x plus 4 plus k squared plus 4 minus 25. That will be k squared minus 21 equal to 0. I'll just recheck my working before moving forward. It's a good idea to do it at this point. 6 times on the left side, 1 on the right. Okay. 4x squared plus 4kx plus k squared minus 25 from the other side. 5x squared from those two terms. This from these two terms. Okay, all right. It looks okay. Let's use b squared minus 4ac less than 0 now. The value for a in this is 5. The value for b is 4 plus 4k. And the value for c is k squared minus 21. Input values in b squared minus 4ac and put that less than 0. So that becomes 4 plus 4k whole squared minus 4 into 5 into k squared minus 21 less than 0. That's a quadratic inequality now. That's a there's a standard process that we've got for that. Let's simplify this. 4 squared, that is going to be 16. 16 plus 2 into 4 into 4, that will become 32k plus 4 squared, that is 16. So that's 16k squared minus 20 into k squared, that will be minus 20k squared minus 20 into minus 21, that will be 420. I just confirm that. My 20 into 21, that should be 420. This is what we end up getting. Let's simplify everything. The k squared term, that is minus 4k squared. The k term is just 32k plus 436. That is less than 0. Now, all of these terms are divisible by 4. What I'll do is I'll divide by negative 4. So the first term becomes positive. That's easier to deal with. I'm dividing the whole thing by negative 4. 32 over negative 4, 32 over 4 will be 8. So that becomes minus 8k then. 436 over 4. Let's just put this on a calculator. 109. So that will be 1 minus 109. We are dividing by negative 4. So the inequality sign, that is also going to change. Okay, it becomes greater than 0. Now it's a quadratic inequality that we're supposed to solve. How do we solve any quadratic inequality? We treat this as an equation first of all. For any inequality, the first thing you should do is treat it as an equation. So treat this as an equation, see what that gives you. K squared minus 8k minus 109 equal to 0. Can we factorize this? If you can't, just put this on in the quadratic formula. Let me just think about whether we can factorize this or not. Minus k, we should be getting 1. We should be getting 8, or multiply k, we should be getting 109. Okay, let's just try random numbers. Maybe 17 and 9. That's a big number. Okay, 15 and 7, that's 105. Okay, so it's not going to work. 16, that'll be an even number, so we can't factorize this. Okay. A lot of times in such problems, you can factorize the quadratic that you get. So I would suggest if you're doing it in an exam situation, at this point, if you cannot factorize the quadratic, it's again a good idea to check your working in case you're doing any careless mistake at any point. So I'll just recheck it again just in case for that reason. So it was fine until this point. 4 plus 4k whole squared minus 4 into 5 into k squared minus 21. 16 plus 32k minus 20k squared plus 420. I subtracted those terms. Plus 32k plus 436. Okay, looks okay. Looks okay. So we'll just solve it as a quadratic equation then. It's not solvable, right? Okay. Minus into minus 8 plus minus square root of minus 8 whole squared minus 4 into 1 into minus 109 divided by 2 times 1. Simplify this, you should leave it in exact form. That's better. 8 plus minus square root of, put this thing on your calculator, 64 plus 4 into 109. And that's 500 divided by 2. Okay. 500, square root of 500, just put this on a calculator. Your calculator will simplify this for you. It becomes 10 under root 5. 8 plus minus 10 under root 5 divided by 2. And that gives you 4 plus minus 5 under root 5. Okay, these are two possible values of k that we're getting. These are solutions of this equation. These are solutions of the equation. Now, what about the solutions of this inequality then? It's a quadratic inequality. This coefficient is positive, so it's going to be a U-shaped curve like this. It has two intercepts. One is 4 minus 5 under root 5, and the other is 4 plus 5 under root 5. Which part of this graph is relevant? It's greater than 0, right? Greater than 0 will either be this part or it will be this part. So what's the final solution then? We say k is either to the left of this value or to the right of this value. So k is less than 4 minus 5 under root 5, or k is greater than 4 plus 5 under root 5. And that will be our final answer. This is what we were looking for. Okay, now since it's a calculator paper, you can actually check this on your calculator as well. For the inequality menu, go down. Right next to the equation function, you have inequality function. Select that. It's a quadratic inequality, so polynomial degree 2. Which one of these forms it is? If I just input the original inequality, which was this one, it's less than 0. We can put this one as well. Either of them doesn't matter. If I put the less than 1 without simplification, minus 432 and 436, that gives me the same solutions, right? X less than 4 minus 5 under root 5. Our variable is k, so we'll say k less than that, or k greater than 4 plus 5 under root 5. And that's our final answer. This is what we were looking for. Okay. Now, when can you use this calculator? You can either do it for verification. That is one benefit of using that function. You can verify your answer. The other benefit could be you could skip this graph thing. So if this confuses you, you will do all of this working until this point, but then to write down the final answer for that inequality. If this graph confuses you, just do this on your calculator and write down the answer based on that. This working is still required. But this curve that I've drawn on this side, that's not required. So you can write down the answer from the calculator directly after that point as well. Okay, that's the final answer. That's what we were looking for. That is question number 8. Okay, I'll be back in a minute. I just need to grab some water and then we resume, inshallah. Just give me a minute. Okay, chale, let's resume. Let's resume and do the next one now. We've got 1, 2, 3. 3 more questions to go. 9, 10, and 11. Let's do these now. Okay, question number 9. It says, show that this thing can be written as 1 plus 2 sine theta divided by sine theta into cos theta. Walaikum assalam assalam. I hope you're doing well. Show that this can be written like this. Acha, dekhiye, in the final result that we want, we only have sine and cos functions, right? We only have sine and cos functions in that. What we can do is, we can convert all of them to sine and cos first of all. Now, what does that give us? Sine theta over cos theta. That's tan theta, right? Cot is cos theta over sine theta, reciprocal of tan. And secant is reciprocal of cos, so we can write that as 2 over cos theta. Now, in the final result, they want a single fraction. So we can take LCM now. What's the LCM going to be? Cos theta and sine theta. So the LCM is just going to be sine theta into cos theta. Highest power of sine is 1. Highest power of cos is also 1. So we just multiply them. That's the LCM. Now, what about the first fraction? We'll have to multiply it by sine theta. So that gives us sine square theta. The second fraction, this gets multiplied by cos theta. That gives us cos square theta. The last fraction, That gets multiplied by sine theta, and that gives us 2 into sine theta. Okay, that was extremely straightforward because sine square theta plus cos square theta now, that becomes 1. So we say 1 plus 2 sine theta divided by sine theta into cos theta. That is what we were looking for. That's our final answer. Okay, that's what we had to show. That was part A. Now they're saying in part B, hence solve this equation for x between negative 180 and positive 180. Now, hence means we have to use the previous part. How is the previous part relevant to this? In place of theta, we just have 2x here, right? That's all that has changed. In place of theta, we've got 2x. That's the only thing that has changed. So what we can say is, since this thing could be written like this, the left-hand side of this equation as well, we could write as 1 plus 2 sine, just replace theta with 2x. In the denominator, you would say you have sine 2x into cos 2x. Okay, so this same expression, just replace theta with 2x. On the other side, you have 0. Okay, now since on the other side you've got 0, what happens now is this denominator goes to the other side, gets multiplied by 0 and disappears. And you're just left with 1 plus 2 sine 2x equal to 0. And the value of sine 2x, that is going to be negative 1 over 2. Now we have to solve this equation. How do we solve this equation? You can do it using substitution. If you've done it that way, that's perfectly okay. That's one idea. You can do it directly as well. It's just a multiple of x, right? We have to adjust the interval. X is between negative 180 and positive 180. The angle is not x here. The angle is 2 times x. Angle is 2 times x. So what's the interval for 2x going to be? Just multiply this inequality by 2, and that gives you 2x between negative 360 and positive 360. So 2x has to be between these two numbers. So now when you look at quadrants, keep in mind you will write all answers in this interval. Find the basic angle. Sine alpha equals, make this number positive on the right side. What's the basic angle that you get on a calculator? Sine inverse of 1 over 2, that will give you 30 degrees. Make quadrants. Sine is negative. Where is sine negative? Sine is negative in the third quadrant or in the fourth quadrant. So the basic angle 30 could either be here or the basic angle 30 could be here. Now, the interval that you're given, that is from negative 360 to positive 360. That means you're going to be looking for values in the positive direction as well as in the negative direction. In the positive direction, you have this one angle, which is 180 plus 30, 210. So you'll say 2x is equal to 180 plus 30, or 2x is equal to 360 minus 30. That will be this next angle. These are the two positive angles that we're getting. You'll also get some angles on the negative side if we go in this direction. The first angle that you get is negative 30. So 2x could be equal to negative 30. 2x could also be equal to this number. What is that? 180 minus 30. But since it's clockwise, we put a negative sign with that. And that will give you 4 possible values of x. The first one becomes 210 over 2, which is 105. The second one, 330 over 2, that will be 150 plus 15, that's 165. The third one becomes negative 15. And the last one becomes negative 150 over 2, which is negative 75. These are the 4 possible answers that you get for this equation. And that's your final result. This is what we were looking for. ठीक है. Is that all right? Any problems with this? Okay, chale, let's move on. Part C. Now they want us to solve this equation where x is in radians. Now, is it relevant to the previous part? Okay, it doesn't look related to the previous parts. It looks like an independent part. Okay, let's look at this now. We have two different functions. One is secant, another is tan squared. Whenever we have two different types of functions, to solve equations, we need to convert them to a single type of function. So we either want only tan or only sine or only cos eventually. Okay. Now, is there a way to convert secant to tan? There's a relation between tan squared and secant squared, but the problem is this is just secant. This is not secant squared. So what we can do is we can convert tan squared to secant squared. That is one idea that we can use, right? We have this identity. We have 1 plus tan squared theta that is identical to secant squared theta. That's an identity that we've got. Using that identity, we could say, or we could actually bring 1 to this side and then apply this identity. So it will be easier to work with. 3 secant of x minus 1, that is equal to, if I bring 1 from the other side here, 1 plus tan square of x minus 1. I can use this identity to convert the right side to secant squared. So it becomes 3 secant of x minus 1. That is equal to secant square of x minus 1. Now we've got secant square on this side, we've got secant on this side. Can we just cancel one secant? Generally, it's not a good idea. In this case, however, even if we do that, it will work because secant of x minus 1, yeah, this will never be 0. Right? This will never be 0, so division by 0 is not problematic here. But generally speaking, the proper way of doing problems like these is you take all terms to one side. Take all terms to one side. That's what I would recommend that you do here as well. So you don't make this habit of canceling things out if they're unknown. Secant square of x minus 1 minus 3 secant of x minus 1. That will be the proper way of doing this. Now what you can do is you can take secant x minus 1 common. That leaves you with secant of x minus 1 minus 3 inside. Now it's factorized form, which means either secant of x minus 1 is equal to 0 or secant of x minus 1 minus 3 is equal to 0. The first equation gives me, if I convert it to cos now, if I take reciprocal on both sides, it'll be undefined, right? Because this is never possible. So if I take reciprocal on both sides, I would end up getting cos of x minus 1, that is 1 over 0. There's no asymptote for cos. Cos is always between -1 and +1, right? So this is not possible. Cos is never undefined. So this means we don't get any solution from this. What about the other equation? Let's convert that to cos as well. First of all, I'll take 3 to the other side. Now take reciprocal. So cos of x minus 1 is equal to 1 over 3. This is something that we can solve. X is in radians. It's between -1 and 3. What you can do for this is you can do it directly as well as we did the previous parts. Another way to do such problems is, which is generally going to be helpful and less prone to careless errors, when you have plus minus something inside the brackets. It's a good idea to use a substitution. It will be a couple of extra steps, but it will reduce careless errors. So since the variable is not just x or theta, it's x minus 1, you use a substitution. You say let a equals x minus 1. Now, if we do that, we were given that x is between -1 and 3. What about a? Input -1 in this, -1, that becomes -2. Input 3 in this, 3 minus 1, that becomes 2. So a has to be between -2 and 2. We get this equation, cos of a equal to 1 over 3. Okay? Solve this equation for a between -2 and 2, and then at the end, you put that substitution back. You could do it without substitution as well. I just prefer it sometimes because it saves you from careless mistakes. Find the basic angle. Find the basic angle. Cos alpha equals 1 over 3. What's the basic angle that we get? Do they want exact answers? Not really. Convert angle on calculator to radians again. This is extremely important. You see, we had to switch our angle unit multiple times during this paper, at least like 3 times in the middle. So it's a very important thing to keep looking at the top of the screen so that you're in the correct mode. Cos inverse of 1 over 3. That's 1.2309. You can say that's 231. That's the basic angle. Which quadrant are we in? Cos is positive. Cos is positive in the first quadrant or in the last quadrant. So it's either this or this. So the two angles that we get in this interval, they're going to be here in the first quadrant or in the fourth quadrant. One of them is going to be A equal to 1.231 and the other is going to be A equal to negative 1.231 in the fourth quadrant, because if we go from the positive side, this will be outside the interval, so we can't do that. But we also have negative values in the interval, so we have to go in this direction. Now you see, adjusting that interval, that is extremely important, because if you don't do that, if you had not adjusted the interval, you would falsely think that minus 1.231 is outside the interval. That interval was for x. The interval for a or x minus 1 includes this value as well. So we have to consider this as well. Now you put that substitution back and you say, this means x minus 1 is either equal to 1.231 or x minus 1 is equal to negative 1.231. And that gives the final result, x is equal to 2.231 or x is equal to minus 0.231. To three significant figures, this is minus 0.231. The first one that we can write as x equal to 2.23 to three significant figures, and that is our final answer. Okay. This was question number 9. This was question number 9. Let's move on. Question number 10. Let's try this now. Okay, now they're saying in this question, time t is in seconds and displacement is in meters. For time greater than or equal to 0, a particle moves on the positive x-axis. So it's moving horizontally to the right side like this. Okay, not necessarily just to the right side throughout, but it's moving on the positive x-axis. That's all that we know. Horizontally. At time t, the acceleration of the particle is 2t minus 9. So the acceleration function is 2t minus 9. At time 7, the velocity of the particle is 4. So we are given a point at t equal to 7, v equal to 4. Find the times when the velocity of the particle is equal to 0. Now, this is acceleration function. How do you find velocity function from acceleration? We have to integrate it, right? Integrate it to find the value for v. 2t squared over 2 minus 9t. Whenever we integrate, we always have a plus c, remember? How do you find the value for c? You have a point given for that. You have a point given for that. T equals 7, v equal to 4. Let's input that point. Put t equal to 7, v equal to 4. And that gives us 4 equal to 7 squared minus 9 into 7 plus c. And that will give you the value for c. Let's see what that turns out to be. 4 minus 49 plus 9 times 7. And that's 18. So the velocity function, therefore, that becomes v equal to t squared minus 9t plus 18. That's the velocity function. They want us to find the values of t, the values of time. when velocity is equal to 0. So put the velocity equal to 0. 0 equals t squared minus 9t plus 18. Can we factorize this? 3 times 6 is 18. So we can use that. T squared minus 6t minus 3t plus 18 is equal to 0. We get two factors from this, t minus 6 and t minus 3. So t is equal to 3 or t is equal to 6. That's what they wanted. They wanted us to find the time. So we are supposed to get multiple answers. These are two possible values of t when velocity is 0. That's easy, 4 marks, nothing complicated there. Part B. Okay, now they're saying at time t equal to 12, the displacement of the particle from the origin is 150. Okay, so at time 12, we are given the displacement value. Find an expression for the displacement of the particle. Okay, let's do that. Find an expression for the displacement. We already have the velocity function. Velocity function is t squared minus 9t plus 18. Okay. What you do now is you integrate it again. Integrate it again, and that will give you the displacement function. That becomes t cube over 3 minus 9t squared over 2 plus 18t plus c. How do you find the value of c now? Again, you're given a point. Input that point here. Put t equal to 12, s equal to 150. 150, that equals 12 cube over 3 minus 9 over 2 times 12 squared plus 18 into 12 plus c. Put this whole thing on a calculator. See what value of c you get from that. 150 minus 12 cube divided by 3 plus 9 over 2 multiplied by 12 squared plus 18 into 12. Sorry. 150 minus 12 cube over 3 plus 9 over 2 and minus 18 into 12. C turns out to be 6 from this. Okay, that's the value of C. Now you input that in that displacement function. So the displacement function that you have is t cube over 3 minus 9 over 2t squared plus 18t plus 6, and that's your final answer. Okay, that's what we were looking for. This has been a fairly straightforward paper until this point, right? Was it negative 18? What was negative 18? I don't think so. It looks like it's positive 18. Is it not? It's plus 18. Achha, now they're saying find the distance traveled by the particle in the first 6 seconds. Okay. Now, if they had just asked you for displacement, you could just input time equal to 6 in this function and you would get the result. But when you have distance traveled, you always have to break the journey at the points where velocity is equal to 0, right? Because those are the points where the object may be changing its direction. So you have to break the journey at those points. They made you find those points in the first part. The time values when velocity is equal to 0. And those time values were 3 and 6. So that means the particle may be changing direction at time equal to 3 and at time equal to 6. Now, time equal to 6 is not important because we're only considering the first 6 seconds. So if it changes after 6 seconds, it doesn't matter. But the 3-second time instant, that is important. So we have to break the journey into two parts, we would say, let's consider time from 0 to 3 separately and from 3 to 6 separately. And we already have the displacement function, just input limits in that. Find first displacement separately from 0 to 3. So what you do is you input time equal to 3 in this, 3 cube over 3 minus 9 over 2 into 3 squared plus 18 into 3 plus 6. Subtract from this the case when you input time equal to 0, and that gives you 0 minus 0 plus 0 plus 6 at the end. Constants always get cancelled out in such problems uh, when you put limits. What are you left with? 3 cube over 3, that's just 3 squared, which is 9. 9 minus 9 over 2 into 3 squared, which is 9, plus 18 times 3, plus 6 minus 6, they will get cancelled. And we are going to get 45 over 2, or you can say, let's just use 45 over 2. That's the displacement for the first part of the journey, from 0 to 3 seconds. Now, what about the displacement for the second part of the journey? From 3 to 6. Again, you input limits. Let's call that second displacement. Input time equal to 6 in that. So that will be 6 cube over 3 minus 9 over 2 into 6 squared plus 18 into 6 plus 6. Again, you could just ignore 6 as well if you wanted. Subtract from that 3 cube over 3 minus 9 over 2 into 3 squared plus 18 into 3 plus 6. Okay, so 6 and 6 were getting cancelled here as well. Here as well, 6 and 6 get cancelled. What I'm going to do now is I'm going to evaluate this from the calculator, see what this gives me. 6 cube over 3 minus 9 over 2, 6 squared plus 18 into 6. And that's giving me 18. Subtract from that this earlier result that we got, 45 over 2. That's the result from these three terms, right? You can calculate it again as well. That's what you would end up with. 18 minus 45 over 2, that's what we're getting from this. Let's see what that simplifies to. Minus 9 over 2. Now, this negative sign is only telling you that the object is moving to the left side in this part of the journey. The object is moving to the left side. That is why the displacement is turning out to be negative in that part. When you are looking for distance traveled, you don't care about the direction. So you would just make those two numbers positive and then add them up together. 45 over 2 plus 9 over 2, and that's 54 over 2, which is 27. That will be the distance traveled that you're looking for. And that's your final answer. ठीक है. Makes sense to everyone. That's what we were looking for. Let's look at the next part now. Question number 11. Next question. Question 11. Okay, now they're saying find in descending powers of x the first three terms in this expansion. Give each term in its simplest form. Okay, now this looks like an easy question at the end. Okay, maybe not the second part. Achha, let's do this now. The first three terms in this expansion, okay, just apply the binomial expansion formula. X squared plus 1 over 2x whole raised to power 9. What is this going to give you? X squared whole raised to power 9 plus 9c1 into x squared whole power 8 into 1 over 2x plus 9c2 into x squared whole raised to power 7 into 1 over 2x whole raised to power 2. They wanted three terms. In descending powers, it's automatically going to turn out to be descending powers. Generally, that's what happens in every single question like this. If it doesn't happen and you want to switch the order, you can just switch these terms. And that will switch it from descending to ascending or ascending to descending, whichever is the one that you want. But generally, whatever they say, it automatically turns out to be that when you apply the formula, considering this as A and this is B. Otherwise, you can switch A and B. ठीक है अच्छा what do you get from this x power 18 9c1 is just 9 into x raised to power 16 in the numerator. In the denominator we have 2x plus 9c2. Let's put this on our calculator. 36 x raised to power 2 times 7, which is 14, divided by 2 into 2 squared, which is 4x squared. Let's simplify this further, and that gives us x power 18 plus 9 over 2 x raised to power 16 minus 1, which is 15, plus 36 over 4, which is 9, x power 14 minus 2, which is 12, and that's our final answer. They wanted us to expand this up to the first three terms. ठीक है. That's what we were looking for. That's our final result. Easy 3 marks. Now they're saying the expansion of x squared plus 1 over 2x whole power n. Okay, this was x squared plus 1 over 2x whole power 9. Okay. Where n is a positive integer, has a term that is independent of x. Show that n is divisible by 3. Okay. Independent of x, what does that mean? Constant term, right? Or you can say x power 0. Okay, it must have a term that is independent of x. The problem is we don't know what the power is. We have to show that that power, whatever it is divisible by 3. Okay, let's think about it. We could say this is A and this is B. If you're looking for a specific term, let's use the general term formula. What does that look like? NCR into A raised to power n minus r into B raised to power r. Input values in that. N, we don't know what that is. NCR, R is, again, we don't know what that is. A raised to power n minus r, which is x squared raised to power n minus r into B, which is 1 over 2x whole raised to power r. Okay, so what we're looking for is the term independent of x. That means the power should be equal to 0. We need to show that n is divisible by 3. Acha, n is an integer, r is also an integer. That is something that we know because n represents the total number, the total power. They said that's a positive integer. R represents the term number. R represents the term number. Term number is also supposed to be positive. Now, let's think of the powers of x. X raised to power 2n minus 2r. That is what we have in the numerator. Forget about the constant for now. In the denominator, we have x raised to power r. Okay, let's simplify this further. This will simplify to 2n minus 2r minus r, which becomes 2n minus 3r. So now what they're saying is, this expansion has a term that is independent of x. Okay, so it has a term that is independent of x. Like the previous expansion as well, next term would have been x power 9, then x power 6, x power 3, and then x power 0. This power 9, it was divisible by 3. So we need to show whenever you have this constant term, this n is always divisible by 3. Okay, this is what we're getting. How do we get a term that is independent of x? That's a constant. This must be equal to 0 for that. The power must be equal to 0. So that tells us the power must be equal to 0. So 2n minus 3r, this equals 0. and 2n should equal 3 times r. Okay, n needs to be divisible by 3. N needs to be divisible by 3. So for now, what we know is 2n is divisible by 3, right? Because 3 times something. So this thing is a multiple of 3. This thing is a multiple of 3. So 2n is a multiple of 3. That is something that we can clearly see here. 2n is a multiple of 3. Can we be sure that n is also a multiple of 3? If 2n is a multiple of 3, if 2n is a multiple of 3, then n must also be a multiple of 3, right? Because if 6 is a multiple, then 3 is also a multiple. Because 2n means an even number, right? 2n means an even number. Uh, 6 is a multiple, so 3 is also a multiple. 12 is a multiple, 6 is also a multiple. 18 is a multiple, 9 is also a multiple. Yeah, so that makes sense. We should be able to prove it like this. Okay, so how do we explain this now? We could say, let's write n as 3 over 2 times r. Now, r needs to be an integer as well. Okay. N has to be an integer and r also has to be an integer. Both of them have to be integers. Okay. So now make sure that you're following this logic now. Remember, n is an integer. N is an integer. And r is also an integer. Now, n is turning out to be 3 over 2 times r. How can n be an integer? Is there any restriction on r for that? We will need to get rid of this denominator. Otherwise, n would turn out to be decimals, right? Because this is n equal to 1.5 times r. So if value of r is 1, that is not possible because n would become decimal. So if value of r is 2, that is possible because then you get n equal to 3. So r equals 2 gives you n equal to 3. That is possible because you get an integer for both of them then. If r is equal to 4, that is also possible. That gives you n equal to 6. If you put r equal to 6, that gives you n equal to 9. So since you have this relation, what that means is r must be an even number. R must be an even number. Otherwise, n would not be an integer. R must be even for n to be integer. And if r is even, if r is even, if I use that original form, if r is even, that means it's 2 times something, right? You can say 2 times k maybe. So n equals 3 over 2. R is an even number, so you can say 2 times k. 2 and 2 get cancelled, and we get n equal to 3 times k. It has to be a multiple of 3 as well. Then n, therefore, is a multiple of 3. Now, it's not necessary that you write r as 2k here and cancel that out to show that it's 3 times this. Just this statement that r is an even number and therefore n is a multiple of 3. That is also going to be sufficient. That's what you would say there. That was quite tricky, to be honest, thinking about that at the end of the paper. But that's the logic. That's the logic. Is that okay? Any problems with this? Any questions? Makes sense to everyone? इसमें कोई confusion है तो बता दें. Otherwise, this is it for today. Just a reminder, these are free AdMath past paper sessions that I'm conducting. If you want to join them, you can have a look at the description or at the pinned comment, which is not pinned. Let me pin that now. Yeah, you can have a look at the pinned comment or at the description to join the past paper sessions. where you will get updates on when we are going to have a particular session and which paper we are going to be attempting in that session. Apart from that, you'll find a lot of other helpful content in the description below as well, like uh, revision videos, difficult questions from many of the recent papers. Have a look at those playlists as well. I'll see you in the next class, inshallah. This is it for today. How difficult was paper one? I've heard that P1 was not that difficult. This was relatively on the easier side. That's what many people are saying. As in, apart from doing careless errors, uh, a lot of people who were well prepared, they must not have lost a lot of marks in that. So if that was easier, you can expect P2 to be maybe slightly harder. But yeah, so from what I've heard, it probably wasn't that difficult. I think somebody shared almost the exact paper as well. I have not looked at that in a lot of detail yet. Maybe I'll look at that right now. Okay, so the first question they asked you to sketch the graph, write down the amplitude, solve that equation, not that difficult. Perpendicular bisector. Okay, this is also fine. Polynomials question is also not that difficult. Circular measure, again, straightforward. Equation of the tangent to the curve at x equals 3, you had to differentiate that function. Okay. Approximate change question, 400, difference is this. Okay. GP. I think it's a fairly easy paper. Apart from maybe the vectors question, the second part that might have confused a few people, and the combinations question at the end of the paper, if you are not left with a lot of time, that might have been slightly tricky as well. I've not tried it. Maybe it's not that tricky. Uh, yeah, it's also not that tricky because it'll get cancelled out pretty quickly. Yeah. So maybe just the second part of vectors question that might have been slightly tricky for people because that involves ratios. A lot of people struggle with that. So it's an easy paper. It's definitely an easy paper. So it's not very difficult. Yeah. Okay, chale. That's it for today then. That's it for today. I'll see you again in the next session, inshallah. Tomorrow we might have a class around 4 p.m., but I'll confirm. I have multiple other commitments tomorrow. Uh, so I'll see when I can manage it, inshallah, and let you know. All right, Allah Hafiz.